There's an idea in archivism where storing some piece of data, it's important to keep a kind of purity, a kind of context, a kind of, well, it's possible for one to think about saving data and to do it and to not appreciate how that data could be used. Because it isn't possible to know what value could be in it. Now, you might assume that there's a certain kind of intention in creating a piece of content, and what's happening is when it's being kept, that intent is being carried forward. So there's kind of an immortality in the effort of the creator. And that's true. That to what extent you can't predict. But there's that's the main drive. That's the thing that people think about when they think about long-term storage. And the thing about that is, when people think in that way, they store information constrained to that, essentially. And so one great example is with images. Images is the classic example. It's fairly recent, and in terms of archiving, it's become more and more common. But back in the day, we didn't have a lot of storage. So there was a very serious constraint. Well, first, there was a constraint in file names, and to a much lesser degree in directory structure. So that's organization. And just disk space wasn't cheap back then. And so what ended up happening is the data got stored, scattered and disorganized across volatile media, and became vulnerable because it was stored on like floppy disks and stuff like that. And some of it in the disk can die, but you can make backups. There were some recovery methods for simple unreadable disks and bits of damage and stuff like that. And quite a lot of it was highly successful. But ultimately speaking, there's a frailty that we understood. And so looking closer to the now, we can say, okay, well, we know better. We've got better storage techniques. We can keep things for longer. But back then, when things were being kept, and images is just an example, we didn't have enough storage space for everything that was interesting. And so the images were compressed and the images were re-optimized. And the notion was, well, the content is there and it's good enough. So you're visually speaking, maybe the resolution of the image was shrunk, but it still fit on your screen, so it doesn't really matter. Or you're optimizing it in the sense that you're reducing the spectrum of available colors, but it doesn't really matter because your eye only sees this and you only need a palette of a certain number of colors. There are ways of optimizing that were performed and are still performed by people who don't know any better, or for the web. And the assumption being that your source is a pure thing to work from, but you compress it to be optimal for a particular context. And so back in the day, images were compressed, and they were considered good enough because they were making immortal the intent of the creator. So you still had the picture of the thing, and it was still there. It's still there at the end. You can still watch it, but things change over time. So for example, it fills my screen. So who cares? Well, now we've got really, really high resolution screens. And although, I mean, technically speaking, that becomes irrelevant at some certain scale. So theoretically, we can take pictures where it's not, in terms of screen real estate, it's not useful to have a huge image. But even then, there's value in having the dimensionality for, say, printing. And that wasn't thought about back then, because we didn't have, say, home printers that could print glossy photograph style stuff. And nobody would have thought about taking the purer data and being able to work from the source and upscale it in certain ways, which is more difficult, less possible, poorer quality with the newer stuff. So nobody, there's all kinds of ways that the intent having been committed to data, the data being carried forward, there's all sorts of stuff that gets lost because nobody really fully understands how it's going to be stored and used in the future. And so there's a concept of purity in archivism where the whole source is kept, and it's a very painful thing to do because there's often constraints of space is the biggest one. Now, I mentioned file names earlier because we used to have the common stuff was like DOS and Windows, which had an 8-character file name limit. It's 8 with a 3-character extension, and that still lingers around, although the file size is much bigger. And in all the file systems that I'm aware of that are contemporary, it's not exactly a file name length limit, it's a full path limit. So it's all the directories and then the length of the file name are all one length that you can use for either pushing it into a very complicated directory structure or very long file names. And I've run into this problem moving stuff from a Linux ext4 file system to a Windows used NTFS file system. It was a pain in the butt to try to figure out how to. I had to rename some stuff and fiddle with directory structure and stuff. It's not pleasant to find limitations like this when you're trying to push an archive around and you run into this stuff. I also had problems with it's a double problem. One is I found that I had data copied to NTFS and I couldn't get at it properly, couldn't use it properly. I was getting errors. And I would later learn that it's because I had been copying from a Linux system data over, and although the data was being copied over, the file name that it was creating for it was not valid for Windows to read. And so I had to boot into Linux and go and correct things, and then Windows could use it all properly. So there's some nuances with moving data around that can make it really awkward. Now we're improving on that quite a lot, and it's not just that all the file systems are getting more advanced, for lack of a word, but maybe we're going to start containerizing things a little bit better so that instead of me taking the data, which is scattered across the structure of the file system that you're presently using for your operating system, I contain it in one file, and then that file gets used by your virtualization layer or whatever, your emulator, and then it can be used inside. This is already forced to be the case for something like if you're emulating a Commodore 64 and you need access to a raw archived 5.25-inch floppy, and you get a .d64 container for a disk, and your emulator would use that, would mount it within the context of the emulated environment, and then you'd be able to use it as is. So we're kind of going to be going in that direction, but we have a universality of file systems it's not intuitive to do right now. So I was talking about image compression, carrying it forward, and problems of file systems. And I was talking about how you can have the context saved. That's the intuitive part. So we save the intent of the thing, and we carry the intent forward. And that's something that we can very easily recognize as the immortality of the intent. But capturing a kind of a fullness hadn't been thought of back then because we just didn't have the file space, the disk space, so we just compressed everything. And it's the same problem with putting stuff up on the web. You might be downloading that extra high resolution poster size thing for that artist, like a band for their poster, or for like a movie poster, or you might be doing something like that, but that there's a source somewhere that you're not getting, that maybe they're keeping, hopefully they're keeping forever. If it's attached to intellectual property, hopefully the owners of the intellectual property will have all those data kind of compiled somewhere and stored, safely. It's because it's their property, and it gets passed around from owner to owner throughout time. So maybe that's going to be the case, but in terms of everyday people with everyday content, they'll fiddle with it over the ages. And one of the things that was given to me as an example is of the value of archiving and the need for keeping the context, for keeping it really, really pure. I'm going to give two examples. One was it's something like you got a black and white picture from the, let's say, 40s or 50s or something like that, and it's a kind of a behind the scenes thing. These days it will be not particularly interesting, but the thing is, if it's taken for a movie that it became popular when it came out on DVD, something like that, but maybe it was a flop in the theaters and it was not particularly notable at the time. Maybe it was a movie adaptation of a play, so it had some history and it was kind of interesting, but it became popular. So people were going back and finding all of the, not exactly memorabilia, but the data equivalent of it. And someone found an old photograph, and they scanned it. And they put it up online, and then their house burned down, so the original is gone. And then that original was carried forward. Now, the intent of its original creation, the creation of the photograph, was there's a scene that they want to photograph. They want to capture still of something they're looking at. And it's maybe the intent was, all these friends of mine that I've been working together, we formed a great bond. It's more than a career. This has been an exciting time. Maybe it was somebody young saying, this is my first job, my first working in a big movie, and they took a picture. And they kept it, and like a grandchild or something like that, discovered it in an attic. And so that's the intent, is this still of life, and it's carried forward. So you might get a scanned image of it, and the scanned image conveys that intent. Although the intent is an idea that has been lost to time, and all you get is a scanned image. You don't know why it exists. You might not know who took it. You might not know really exactly when it was taken. And there are situations where you actually don't even know the names of some of the people that are in the picture. You don't know where it was taken. And there's some stuff where the metadata is just so gone that you just have a big question mark and an interesting picture from back in the day. But let's say the intent was carried forward, but you don't have, like, maybe there's the initials or the signature of the cast on the back of that picture, which wasn't scanned because that person was interested in archiving the image itself. So that's one thing that they never thought of. The other thing is, well, that intent was carried forward in the picture, but somebody in the far future might look at that picture and say, oh, wow, that's that piece of equipment that was used in filmmaking back then. I didn't fully know how it was set up, how it was poised, and how it was being used, but there's somebody in the background that's actually working on one of those. And they can examine the picture from a perspective that might have been obvious to the person taking the picture back in the day, but it wasn't cooked into the intent, and it wasn't understood as part of the desire for capturing the thing and carrying it forward. And so having, let's say, an extremely high resolution scan of the photograph might be extra valuable. So it wasn't necessary that the person needs to print it, but they need to analyze it a different way. And there's also stuff that happens in say, compression in the image where, so the scanned image, let's say, where they compress it and they lose some of the pixels. They declare it as being they only need to have 16 shades of gray. And that's what they did. And there was some detail that was lost. There were some jagged edges. And this really impacts some subtle thing in the background that the creator of the scanner didn't know might have been valuable. And so there's a story that happens when creating an archive of stuff where if the intent is almost ignored and it's the data that's being preserved without any kind of judgment as to why or how or anything, it's just 100% as perfect as possible. It's not recaptured in today's, like the idea of today's data. And so another example is something like a compressed file. Okay, so this one's going to be a little bit difficult for me to describe. So again, disk space was expensive back then, and some of our mathematics was a little more rudimentary in terms of discovering ways of compressing information. So you'd have archivers, and there was a whole lot of variety of archivers back in the day because, anybody could write software, not that it was easy, but anybody could write software. There were a lot of different ways of approaching the problem of taking a source file, compressing it down to something smaller that represented the data that could be exploded again and returned to its original state, like 100% returned to its original state. I had there are archivers that could also deal with like compressing images, and they would be lossy, and they would automatically do certain things that I can talk about after. And so you can imagine that somebody back in the day, they were using like version 1 of the archiver, and then version 2 came out, and version 2 was significantly better. So they took all their data, they took it from the original, and they unpacked it, and then they repacked it with the new one. And they don't need the other one anymore, so they deleted it. Now, and they do that again and again and again until they have today's latest and greatest format. Now, time is going to pass, and that current at the time format will have fallen into disuse. And so somebody in the far future will always be looking at these snapshots like they're old data it's difficult to work with, especially if it's something that's proprietary, if it's something that's not openly documented, if the actual archivers that were being used for it aren't stored kind of alongside it, so that you can't like emulate the entire environment and the file system and all the files and then take the actual software that was used to work with it and use it like in the original environment that the archive was created in. You can't, there's all kinds of problems with that. So, but the distance of time is always going to make some of it dated and difficult to work with. But because the data inside that archive has been carried forward, exploded and contracted again and again, what if there was value in the original data that was compressed way back when, inefficiently with that older version of the software? If there are nuances in there that could be useful for archivists in the future to actually study the compression technique that was being used back then, for whatever reason, for historical interest, for things that we can't guess at, they wanted to understand our understanding. They wanted to gauge our understanding of the underlying mathematics or something like that. Things that we would think are just dumb right now that might be interesting or potentially very useful. So somebody doing a PhD thesis on the history of mathematics in algorithms in file compression of text files would be able to go back with all of these different versions of archives for version 1, version 2 going forward, they would have access to that. Or it could be something really simple like, okay, I'll give what should be a really embarrassing example for Microsoft. So Microsoft, I believe it's Microsoft Word that did this. It might be Excel. I'm going to say it's Excel. Now, computers were particularly slow in the context of what they were working on back then. And so you can say computers are kind of always slow for what they're presently working on, because you're working on more and more complex, with software that's more complex, doing more complex things. It requires a faster computer, and they kind of like match one another. And back then, you were doing some pretty spectacular things on a computer that wasn't quite able to manage it. So things were really slow, and there was a concept of patience that doesn't exist for working with current computers. And so you're working with a spreadsheet of any size, and one of the problems is saving what you've got out to disk, because there was a justified concern about losing data if there was a problem somewhere. And if you're working on something particularly complex, like the data in a spreadsheet, it could be very important stuff. Being able to save regularly was very important. So it had to happen fast. And so what Microsoft did is, and this was only discovered well after the fact, which is, and as soon as I found out, I checked for myself to confirm it. For other software. So what they did is, instead of looking through you can imagine something like, this is wrong, but you can imagine you've got a table of different cells with all the data in columns and rows, and would go and look at like, well, this is A1 has this data in it, these numbers, and A2 has these data, and would take all that and would put it into a text file bit after bit after bit. And so it would look at this, and it would look at this. You can imagine it's kind of like taking one page and then dropping it down into one single line of stuff and trying to compress it down a bit. So you've got one file made of one string and one stream. That's not exactly what they did, because you'd have to do the opposite. You have to read this file bit by bit, uncompress it, and then unravel the thread out into, kind of weave it back into a spreadsheet to do the reverse. And so one was slow and the other was slow. So what Microsoft did is they were naughty. And when the program runs, it allocates a certain amount of space in memory for the software. And that space might grow or contract, but it was of a certain number of units of size that was predictable to the program. And the way it did it was it had a start point, and then it requested from the operating system an end point. It just captured it all. It's like, okay, can I use this bunch? And the operating system says, yes, that's available. And it says, okay, I'm using all of this. And then it would take all that data, instead of looking at the cells at all, it would just take that block of memory, and then it would just write it to disk. The in-betweens just didn't happen. It would just drop it down into a file. And so it probably had a larger than necessary file for sure, but it was a lot faster than it might have otherwise been. And Microsoft did had strategies for making software that was better than the competition. And this was one of the things that they did. But the thing is, and you can't say that they didn't know, because they're not bad programs. They're really amazing. Like, one of my favorite pieces of software was written by Microsoft, and it's absolutely astonishing how good it is. And I know they're smart cookies, so I know they knew about this. What they did is when they were capturing the data, when they were requesting the space of memory to work with for the spreadsheet, the operating system would just give it to them. It wasn't judging. Didn't know what it was for. It's like, okay, well, and the spreadsheet got that and was working on it as it was working on it. But the thing is, it was not blanking the page, the full space. So when it was writing it out into disk, it was just dropping it as is. So the operating system took all the data, gave it, the spreadsheet took all the data, grabbed it, and then it just dropped it into a disk. Now this relates to archivism. So you've got these files, and keeping the original, as opposed to going from version 1 to version 2 to version 3, keeping the original is particularly important because in this case, they fixed this problem with version 2 problem. And with version 3, nobody had ever heard of it. So if you took version 1, opened it and saved it again in version 2, which would become the default because it's better. Hey, we've got smaller file sizes now. We're more efficient. This new file format also allows you to have text with italics in the spreadsheet, stuff like that. So you got to save it in version 2 because version 1 doesn't support that stuff anymore. And people would take their same old stuff, would pull it forward, and so you'd lose version 1. But the thing about version 1 was the operating system didn't clear that memory. The spreadsheet program didn't clear that memory. When it saved it saved all of that memory, including the stuff that had never been touched by the spreadsheet. And you might think, well, all those cells are empty. So, I mean, what's the problem? But the thing is, it wasn't going A1, A2, A3. It was just capturing the memory. And the captured memory happened to have included whatever other programs had been using that memory. And whatever programs that happened to be using that memory might not have gone through all of its memory when exiting to go turn that into a 0, that into a 0, that into a 0. So it still had some of its ones and zeros in place, in memory. And because those programs wanted to exit really quickly and didn't want to go do that cleanup themselves. And maybe they thought, well, the operating system should do that, or the APIs, and it never happened. So the Microsoft spreadsheet just grabbed all that and dumped it to disk, and it included remnants of the memory that had been used for other programs. Now, version 1 of that now includes stuff outside the context of the original creator. It's got more than the accounting for that small business for that 1 year. It's got a snapshot of fragments of the memory of other programs that might have been running on that computer. Not necessarily even simultaneously, because you might not have had multitasking. So this is a Windows program that I'm thinking of. But you can imagine that there's other programs that might be running at the same time or had been running recently and weren't reused or were partially overwritten. So it's kind of like an unintended kind of a jumbled mess that's there, but it's there. There's data there. And at the time, people didn't know about it. And there was ample opportunity for that data to be destroyed by newer, better format. But if you get version 1 of that software, now you've got access to this other stuff. Now, you might not be interested in it. If you're an archivist, you would just maybe if you're an amateur archivist, like you're in accounting for that software, you look at that. Oh, well, they just gave me an ancient hard drive with a whole bunch of spreadsheets on them. So what you do is you copy and paste them, bring them into your environment, and then one by one you open them and you look at it like, okay, this is this year. Save it with your nice new long file name. Save it out in version 2 because it's a smaller thing. It's whatever reason, it's the default, and that person isn't really an archivist. They're just an accountant that cares about the past history, and they go through and do all that. And then the hard drive's old, so it gets thrown out, right? And maybe somebody somewhere else gets it at secondhand, and they format it and they kind of use some of it, and there's gold there that they don't quite recognize they have. An archivist would look at that and see version 1 of those files on that hard drive. would see the directory structure, would see the original file names, would see the wholeness of it and keep all of it, because there's no way of knowing what nuances could be hiding in anything. Maybe these things were all zipped up into their own little containers, and there's like metadata on the archive file that says when it was archived, by whom, who the login was, or other little notes that were stuck in the archive that nobody would recognize. They just unzip it, compress it with something better, and they lose all that information. Maybe all kinds of things could happen to it that would destroy that information. And it cannot be known what tainting can happen when somebody who is kind of interested well enough, but they're only interested in keeping the original intent. They're not interested in, they don't think to keep the original absolutely flawlessly perfect. There could be information that's lost that could be interesting to people in the future. And we've already got circumstances such as, is it Diablo 2? It's a video game by Blizzard, now Activision Blizzard, who had created a groundbreaking game, and they lost the source code. How that happens, who knows? But it happened. And they wanted to bring it forward and re-release it. Give an updated version of it with new graphics or whatever. They wanted to take it and turn it into a new product that they could sell. And they couldn't, because all they had was a working game for like ancient platforms. I think it was Diablo 1. And they had it for, it was originally a PlayStation 2 game. And there was and they couldn't pull it forward without all kinds of a mess of wrapping it with emulation. And then it was hard. And yet there was a version that was released, and it unintentionally released wrong because it had extra data in it. It was playable. It was perfectly playable. Nobody knew anything about any of this extra stuff that was put on it, but the programmers left debugging symbols on it, which is when taking their source code and compiling it, it compiled it and it had some leftover stuff, so it could recompile a second time, or so when it's executed, it could run with certain bits of understanding there, so it could communicate out and dump logs and be examined by third-party programs and all this. So there's programmer-related stuff that has nothing to do with a player's interest. Normally that would be stripped away because it's kind of like secret. It's kind of part of the proprietary nature of the software, and you need to keep things nice and small and trim and simple for players to get. They only care about the playable stuff, so you need to make sure you only give them that stuff. You don't want to have these things. You don't want to have like Easter eggs turned on or anything in the game. You don't want to have developer-only cheat codes available in the game. You want to turn all that stuff off before you release a game. And sometimes this stuff gets forgotten about, and it's discovered, or it's smart people go in and figure out how to flip the switch and turn it back on. In this case, the software was released more fully, and it had this extra stuff on it. And incredibly brilliant people could take the closed source playable software with all of that other understanding in mind, and take it and not quite reverse engineer, but use that to make source code again out of all of that. And from that, it was still significant effort, but it's not rewriting it from scratch, but it was significant effort. But they could turn it into working source code again, and then use that and adapt it for today's software. And so that's a circumstance where things were unintentionally made more thorough, more full, more 1.0, and it was kept out there unintentionally on archives, and people kept the old disks, and those old disks turned out to be extraordinarily valuable for some future generation. They never would have guessed at the value of those disks, and the future generations could walk through, could get the originals kept in that more pure state, and then could could do great things with it, even if it's just a game. Like just a game, but it's also a piece of history. It's also something that makes more money for a business, which matters. And so that might have been key in them essentially selling a new product that makes more money, that funds some new project that wouldn't have otherwise happened because number crunchers would have balanced things out and would have said, well, we don't have enough of a budget. It's too risky. We're not going to do that. But now that they had this thing in and it made a bit of money, now they've got that confidence as well. And they can say, okay, well, it's a little risky, but we had this extra money. So like it cannot be known how old data in what state could be useful for what purposes and what impact that could have moving forward. So just like keeping the old photograph, or just like keeping the old spreadsheets or the old archives or the old games, keeping the source code around somewhere, keeping it in better shape than on floppies that rot in a closet. Keep the original photograph if you can, so you have both sides of a picture. Like maybe the material the photograph was printed on matters to someone somewhere for the most obscure reason. Somebody trying to understand our technology, trying to understand how we were working with paper or with the printing techniques or what, and it has nothing to do with the original intent of its creation. It's just the pureness that archivism can capture to bring something forward without any kind of judgment whatsoever, to make it possible to use any particular bunch of data for unknowable purposes.